To understand why legacy corporations are failing in 2026, you have to look at how they structure their decisions. Traditional organizations rely on multi-tiered departmental approvals to execute standard procedures. In an economy moving at the speed of generative artificial intelligence, waiting for a committee to draft a project charter creates a catastrophic operational liability. Competing firms are abandoning the structure. They are deploying modular talent pods, small, specialized teams that dissolve and reform in real time to execute complex projects before a traditional firm can even begin. This method of operation requires instant intelligence scaling. Matrix organizations built on strict hierarchies lack the architectural bandwidth to process data and deploy human labor at this velocity. Managing an enterprise as a collection of static job titles is incompatible with survival in the current economic design. The drive toward fluid teams is a direct response to the macroeconomic realities of 2026, which have inverted the old logic of accumulating permanent headcount. Businesses are facing an exponential rise in computing costs associated with generative artificial intelligence. This is known as inference economics, and it forces organizations to rethink how they allocate capital between silicon infrastructure and human labor. Compounding this compute expense is a deeply contradictory labor market. With sticky global inflation hovering around 3% and robust wage growth, traditional hiring models have become prohibitively expensive, compressing profit margins. Data shows a 2030 talent deficit of 85 million people, creating an $8.5 trillion gap in unrealized revenue from unfilled static roles. Escaping this trap requires shifting to a highly liquid talent ecosystem, sourcing labor dynamically instead of maintaining permanent payrolls. Talent has evolved from a localized human resources concern into an existential capability problem requiring an entirely new architectural blueprint. The global labor market has shifted to support this demand. Independents now constitute 44% of the U.S. workforce, providing a pool of highly skilled project managers, technical architects, and executives who prefer operating outside traditional employment. To integrate this liquid market, enterprises use the core flex architecture. This structural framework bifurcates the organization into two distinct layers to treat human capital as a highly elastic variable resource. The core acts as the stable center of gravity. This nucleus consists of long-tenured, full-time practitioners responsible for maintaining cultural continuity, long-term strategic vision, and mission-critical proprietary systems. Surrounding this nucleus is the flex layer. This elastic ring of freelancers, gig workers, and specialized consultants expands and contracts, deploying specific skills for short-term project scaling at high velocity. A critical component of this outer ring is the corporate alumni network. Former employees possess a granular understanding of the internal culture and systems, providing frictionless capability injection without the overhead of cultural onboarding. When a leading financial services company faced a crisis of retiring legacy mainframe experts, they deployed a managed capacity core flex model. This allowed them to simultaneously onboard a cohesive team of external specialists to stabilize uptime without scattering institutional knowledge. By treating talent as a variable resource, organizations execute precise capability injections in a matter of weeks, bypassing the months typically required by standard procurement cycles. Operating a core flex model requires dismantling the traditional job description. This transformation relies on the skills-based organization model. Under this framework, talent is treated strictly as a dynamic inventory of granular capabilities rather than a list of static titles. When a critical project arises, the enterprise's algorithms do not search for a manager. They route the work directly to a verified, synthesized cluster of the specific skills required to execute the task. Data indicates that skills-first hiring is 5 times more predictive of future job performance than relying on historical academic pedigrees. The primary hurdle to this transition is the lingering psychological bias towards prestige hiring among legacy managers. To overcome this, human resources departments deploy artificial intelligence mapping tools to prove that internal candidates often possess the requisite capabilities, even if they lack the traditional title. This system relies on embedded continuous learning. By utilizing AI agents to push microlearning modules precisely when employees encounter operational roadblocks, organizations tie upskilling directly to immediate business outcomes. The skills-based model transforms static headcount budgets into dynamic, high-yield capability inventories, maximizing internal mobility and lowering external recruitment costs. Integrating autonomous AI agents into this fluid network introduces severe logistical challenges. To prevent chaos, leading organizations are intentionally architecting the workforce into interoperable micropods. By reversing traditional hierarchical communication structures, they force the creation of agile, highly integrated enterprise outputs. This is executed through the Team as an API management framework. Every talent pod operates exactly like a software microservice, defining clear, codified endpoints and guaranteed service-level agreements for its interactions with other teams. The first topology consists of stream-aligned teams. These are the core engines of the enterprise, structured around specific product lines and focused relentlessly on a continuous flow of value delivery to the end customer. Supporting them are enabling teams and platform teams. These highly specialized transient pods are deployed specifically to bridge acute knowledge gaps, build internal digital infrastructure, and reduce the cognitive load of all other groups. Finally, complicated subsystem teams are dedicated pods that manage deeply technical, niche components, such as proprietary mathematical algorithms requiring intense cognitive focus. In this framework, the role of human management is unbundled. Autonomous orchestrators handle high-volume data routing, elevating the human manager to a strategic coach who monitors cognitive load and applies nuanced ethical judgment. Institutionalizing these lines of communication eliminates the ambiguity, political friction, and hidden dependencies that stall traditional organizations. The theoretical architecture of the liquid workforce is actively generating measurable financial returns within global technology hubs. The IT and engineering ecosystem in Pune, Maharashtra, serves as a premier testing ground for these methodologies. Local academic institutions and industry chambers have integrated to champion these liquid workforce models, elevating skills-first frameworks through multilateral dialogues on the global stage. At the enterprise level, firms utilize the GCC Copilot framework. GCC stands for Global Capability Center, which is a specialized offshore facility built by an organization to handle specialized IT or business processing work. This framework evolves these centers from static cost arbitrage hubs into AI-native transformation engines by embedding targeted talent pods into engineering workflows. Similarly, platforms like Prismforce deploy an AI-powered talent supply chain. By utilizing advanced intelligence to unify scattered skill data, they enable frictionless internal mobility and targeted succession planning. The application of these domain-trained pods deliver margin expansions of 30 to 50%. Chief financial officers now champion the transition toward modular talent pods as a primary strategy for capturing market share and securing measurable financial performance. While AI-orchestrated talent pods offer immense operational velocity, deploying opaque algorithms to evaluate and direct human workers introduces severe systemic vulnerabilities. The most pressing structural danger is the hollow middle. In a rush to optimize costs, organizations automate foundational analysis and entry-level logistics. While yielding immediate efficiency, eradicating the bottom rungs denies the next generation the experiential repetitions necessary to develop complex judgment. If this pipeline is severed, the enterprise faces a deficit of senior leaders capable of managing the very AI systems that displaced the junior workforce. This automation also triggers an intense psychological toll. Workers subjected to constant algorithmic surveillance frequently fall into the authenticity trap, altering their natural behaviors to mimic the narrow parameters rewarded by black box algorithms. The pursuit of pure algorithmic efficiency erodes the internal talent pipeline, eventually dis-skilling the workforce and undermining the organization's future leadership capacity. To mitigate this existential threat, organizational architects are advocating for a shift away from pure efficiency routing toward curriculum-aware task routing. The AI orchestrator does not simply assign tasks to the fastest node. It tracks the skill progression of junior members, intentionally allocating tasks at the boundary of their capabilities. Acting as a developmental coach, the algorithm generates the experience required to preserve the learning pipeline. This ethical governance is also being forced into reality by robust legal blowback. In the European Union, the enforcement of the AI Act has officially classified the use of artificial intelligence in workforce routing as high risk. Organizations are now legally required to deploy explainable AI, or XAI. XAI is a set of processes and methods that allows human users to comprehend and trust the output created by machine learning algorithms. Furthermore, top-tier professionals are enforcing a candidate bill of rights, demanding total transparency regarding how automated hiring and task routing decisions are executed. Enterprises dominating this decade will abandon static roles, govern algorithms with rigorous ethics, and architect human capital for continuous, modular flow.